So here's my big question to you. How many of you see growth by 8% and can immediately go into your head and say that's a multiplication by 1.08? Is anybody familiar with that? Yes? All right, so if you're not, let me show you where that came from. That 1.08 came from taking 100%. We always start, yeah. Are they not back there? How'd these end up here? Anybody else missing them? All right. When we are talking about exponential growth or percent growth, we always want to start with 100, and depending whether it's growing or decreasing, this one's growing by 8%, we add or subtract from 100. So the idea is you keep 100% of what was there already, and then you either add or subtract whatever percentage it's changing by. So 100 plus 8 is 108%, and then we change that into a decimal, and that's where I got this 1.08 from. Once we have it as a decimal, then we can just multiply by whatever we started with and get our answer. So to answer this question, I would take 3,650 people and I'd multiply it by 1.08. I'd stick that in my calculator and I would get, so I'll just save you a couple seconds here, 3,942. All right, so 1.08 would correspond to an increase of 8%. You guys, is that okay with you? Show me it's okay. If I increased by 12%, what would my multiplier be? 1.12. If I increased by 20%, what would my multiplier be? 1.20 or just 1.2? If I decreased by 5%, what would my multiplier be? 0.95, right? 100 minus 5 is 95, so 0.95. We good there? All right, so a $60 hoodie is 30% off. Can you guys do this in your head, or do you got to use an app for this when you're shopping? That's a $42 hoodie. That's easy. It's 42 bucks. Well, you don't need a calculator. If it's 30% off, how many percent are you paying? 100 minus 30 is 70. 70% as a decimal is 0.7. And 0.7 times 60 is, how do I just know that? Well, because I know that minus 30 is 70, and I just multiplied 7 times 6. And then I was like, there's some zeros in decimals, so it's either 42 or it's $420 or it's $4.20, and the one that made the most sense was 42. All right? So, all right. So we're going to do some modeling, and we'll be using this concept over here to find our B value, our multiplier. You guys need to move apart. Can you just move over a couple seats, please? This is the third time I've had to ask. Okay, just reviewing. A is our initial value. Over the next one, at least. And also our y-intercept. B is our multiplier, or our base. And the book introduces this whole thing. We're going to skip it today. It's not necessary. It's the same thing. It's the same thing. So we're skipping this. Feel free to read about it in your book if you like. I'm going to show you in our first example how you would set it up using this model instead, but you'll see it's going to be the exact same thing, okay? So here we go. We have a colony of bacteria that, some people got upset about this earlier, so let me preface, these are bad bacteria. They're bad bacteria. They're like infecting stuff. They don't have families. It's okay, okay? No friends. They're bad. They're like, it's an infection. We're happy that they're dying, okay? We're going to start with 8,000 of them. We're going to start it with 8,000, and then 22% of them are going to die every hour, and that's a good thing. That's a good thing. So So 8,000 cells to start off with. So that's going to be our A value, right? That's our initial value. And then 22% are going to die off every hour. So I'm thinking in my head, what's my multiplier going to be if we're losing 22%? So remember, we always start with 100, and then add or subtract. Minus 22, and that's not 88. 78%. So what's my B value going to be? 0.78. Okay, we lose 22. That we do 100 minus 22, we get 78. Change that to 0.78, and let's write ourselves an equation. Y, or f of x, equals A value comes first, 8,000 times B was 0.78 to the x power, and that's great. That's it. I told you that I would show you how this would work with the exponential population model. You can go back and learn about this if you want. Let me show you what it would look like if I did that. It would be p to the t equals 8,000 times 1 plus, except r is going to be negative because we're losing 22%. So minus 22 as a decimal is 0.22 to the t power. Can you see that those are the exact same thing, except with p's and t's instead of x's and y's, or f's and x's? All right. The only thing that I do want to tell you about this is, do you know how to pronounce this little thing here? This is P sub 0. This is a subscript, and in science, it usually means it's a starting value or initial value. So if you ever had T sub 0, that would be like your initial time, or capital T sub 0 might be your initial temperature, but it usually means where you started out. Some people call the little 0 a naught. Some people might refer to this as P naught. If you ever hear that, that's just like British English for 0. Have you ever heard a Canadian or a Brit say naught instead of 0? Yeah, naught. N-A-U-G-H-T. It's naught. Yeah. You ever heard of a game called Noughts and Crosses? You ever play Noughts and Crosses? You have. Yeah. It's called tic-tac-toe here. And in England, it's called Noughts and Crosses. Australia, New Zealand, Commonwealth folk. All right. So we're not going to bother with that because it's the same thing. So how many cells will there be at midnight? Midnight, that's a time, so they must be giving us an x value. What x value are they implying here? We started at noon. Midnight would be x value of 12. So let's just take 12 and put it in for x in our function. We'll just find f of 12. And we'll let our calculator do the heavy lifting here. Type that in your calculator. I think we're going to see about that. We had some discussions about how to round this. I think if I were doing this like in a serious setting, I would probably round it to 400. We're talking about really tiny cells. We could be off by 6. Some people are like, can you have a portion of a cell? Shouldn't we always round down? Or? Nah, so if you can justify your answer, no. And if I ever do, and you can justify your answer to me, I'm flexible that way. Yeah. Especially if I'm not being super specific in the question, it's hard for me to expect you to be super specific about your answer. So if I didn't say what to round to, how many cells, yeah. That's a good question. Okay, when will half of the cells be dead? Well, that would mean half of them were alive. And how many would that be? We started with 8,000. When half of them are gone, how many are going to be left? They just gave us a y value. They gave us a y value of 4,000, and they're asking us to find an x value. So I'm going to go back to my model here, and I'm going to plug 4,000 in for y this time. And that gives me an equation that we don't know how to solve algebraically yet. So what are we going to do instead? Let's graph it. And, okay, so don't touch those calculators yet. No, hands off. Okay, if I can get you to do this now, it's going to make you much better at this in the future, okay? Because we'll be dealing with this next semester a lot too. The hardest thing for most of my students, and also anecdotally probably for AI to do, would be to set the window on our graphing calculator for a particular word problem, okay? That's where my students struggle. You're not going to have trouble with the math on this assignment. It's going to be how do you get my window so that I can see what's going on. So here is my best advice to you is don't touch your graphing calculator until you've made a sketch of it on your paper. This is also going to be good for your learning in terms of like how can I predict what I'm going to see on that calculator. Okay, so what do we know so far about this function? Tell me whether it's increasing or decreasing. It's decreasing. And what's the y-intercept? 8,000. So I think when I set up my window, I'm going to set it up so that this is time, starts at 0, and 0 cells would be down here. So the origin's actually going to be down here in the corner. And we're going to start with a y-intercept at 8,000, and that's going to be the highest point that I see. So it can be pretty close to the top of my graph. So I'm going to put 8,000 up here. And I know because it's an exponential function that it's going to come down and it's going to sort of level out as it gets closer and closer to the x-axis, which will be the bottom of our screen. Give me a point that I know already is on this graph, x and y coordinate. 0, 8,000, I already got that one. Give me another one. 12, 406, right? About-ish. So, and that's pretty low. 406 would be like way down here. So that's probably going to be pretty far off to the side. But we are going to have like 12, 406 will be on there someplace. So if this is what my graph looks like, this is going to be 12 here. So tell me, how far out should I go in my x direction? I want to go a little bit further than this. 15, 20, your choice. I'm going to go 15. But do you. And then what about in my y direction? How high up do I want to go? I want to go a little higher than 8,000. 10,000. All right, we'll go 10,000. That'll get us a bit above. And wait, don't type it in yet. Guys, please stop. Please stop. When we do this, we're going to want to have a horizontal line. Where's that horizontal line going to be? At y equals 0? No. 4,000. We're looking for when it's half of them are gone. So if I were you, my habit is to set the window first and then type my equation in. I see many of you are jumping and doing the opposite direction. Then I'm going to hit y equals and type in my function. Not to the 12th. Ooh. You know what? I did this earlier today and we got some troubles. What did I do wrong here? What's wrong with my equation in my calculator? I don't have an x in there, do I? That's not going to graph. It's going to graph a horizontal line at 406. I don't want that. I need an x in there. Did you also graph a horizontal line at 4,000? You're going to need 2 graphs on your screen. And then hopefully if we've done our job thinking about that window, we should actually be able to see what we want. That's actually pretty close. Now what are we looking for? What was the purpose of doing this? When will so at 4,000, so we need to figure out when that happened. Basically, we need to figure out the x-coordinate of this point here, where they cross. We could check the table. Actually, your graph can find intersections. Yeah. So that's under the calculate menu. Could I get you guys, does anybody need a moment? Because I'm going to show you, I don't think we've done the intersect before. Maybe we have. second calc, and then option 5 is intersect. It's going to ask you for 3 things, first curve, second curve, and a guess. The curves are just the y1 and y2 and y3. If you go up and down, you can select between them. Here's the shortcut though. If you only have 2 functions in there, just hit enter and enter. And then when they ask you for a guess, if there's only one intersection, just hit enter again. You don't actually have to move over to that intersection. It'll find it. That guess, the only time you need to use that guess is if you have like multiple intersections and you need to tell the calculator like, I want the one that's over here, then move your cursor over towards it. I'm coming up with about 2.789758. Does that sound like what you guys are getting? So we'll round that off to what, 2.79? 2.79 what? Hours after when? When do we start? Noon. So 2.79 hours, 2 something, 240 something. All right. So that answers this question. All right. Last question here on this example. What's the half-life of this bacteria or colony of bacteria? What's the half-life of it? Do you guys know how to find half-life? Have you heard of half-life before? We did it last year. It's been a while. My students kind of sometimes they have bad memories of half-life. You were right. It is 2.79 hours. What is the definition of half-life? Yes, the time it takes for something to go, for half of it to go away. Isn't that what we just found? Yeah. That's what the half-life is. When are half of them going to be left? That's the same question as asking what is the half-life. So let me ask you another question and see if you understand that definition. Are you ready? So at noon, we had 8,000 cells, and then I waited 2.79 hours, and I only have 4,000 cells. If I wait another 2.79 hours, how many cells will be left at that point? 2,000 cells. If I wait another 2.79 hours after that, how many cells will be left? 1,000 cells. Okay, we got it. Let's move on. Baseball cards. There's a lot of information going on here, so I'm going to go ahead and make a table. Wait, what are we waiting on? No such thing. Every 2 point. Yeah.
So is that why? So does it reach 0? Never.
Good question. That's an excellent question. Is it ever going to reach 0? Well, we talked about exponential functions. Do they ever get down to 0? They get really, really close. Now, in the real world, is it ever going to reach 0? At some point, there's going to be 1 cell left, and whatever is killing everything else is probably going to kill it too, right? Yeah, so it depends on the actual situation. Like in the real world, yes, we get to 0, but theoretically, no. I know, isn't that crazy? So that means there's still germs on your hands from 20 years ago. No, you're not that old. From 10 years ago when you washed your hands, because it didn't get them all, and some of them are still there. I know, crazy. No, I mean, in reality, things do get to 0. Yeah, this is a model. Model is like close to reality. Mm-hmm. Yeah, but it's never actually, in theory, it never would get to the horizontal asymptote. But in a real situation, it's going to get to 0. Eventually, there are 0 cells left. Unless there's that one that's just like really tough and goes on forever. what do they call those little things that live in the ocean? Water bears. What are those? They like live forever and they're tardigrades. That's what I was thinking of. They look like little aliens. Okay. Baseball card. Well, this is about the value of a baseball card. So my Y values are going to be dollars. So the first value that we see is $870. That was 5 years ago. I'm just making some notes for my off to the side. That's 5 years ago. $870. And then today, someone thought it was worth $1,225. And then the question is, first of all, what's the annual appreciation rate? Annual means every year. And appreciation, have you heard that before? It's like an increase, it's a percentage increase. Do you know what the opposite of appreciation is? Depreciation. So we have heard this before. Okay. Depreciation, appreciation. Anybody going into accounting will deal with a lot of that stuff. They want to know if that rate holds, how much is the card going to be worth 20 years from now? So I'm eventually going to figure out my Y value for that. And then how long is it going to take before the value goes up to 0.5 million, $500,000, $500,000? And I don't know how long that's going to be. So when we set the starting value, it's totally arbitrary. I could make this be the starting value, or I could make this be the starting value. If I wanted to, I could make, like, I don't know, 18 years ago be the starting value. I don't know why I would, but it's totally arbitrary. So what do you guys want to make the starting value? You want to do today? Now, if we do today, if this is 0, then what's my X value going to be here? -5. Do we want to deal with negatives in these? I'm going to, so it's totally possible we did it in last class and it worked out just fine. How would it make sense? So if anything, if today is year 0, then last year would be year -1. And the year before that would be -2. It would be on the negative side in terms of the X coordinate, but yeah. So when we do, so I love that you're already thinking about graphing. I think this is, let's go ahead and make a sketch of what this thing's going to look like. We're gonna eventually need it. I usually wait a little bit. I like that you're thinking already about what it looks like. So if we did this, say this is year 0. These are my years. First of all, is this growth or decay? It's growth. So we're going to see something that's going to have a y-intercept and it's going to go up like this. Okay. So if we decide for year 0 to be today, right? Are you with me? If we decide for year 0 to be today, then when I go out to do that -5, we're going to be going over this way. But that's okay because it's just going to be a lower value. We can talk about -5 years. It's still going to be a positive value on the card. -10 years would be even lower than that. So you're looking back in time from year 0. Now I'm gonna suggest that we make this the initial value. The math comes out cleaner if we do it that way. But if you want to try it, if anybody's up for a challenge of doing it with the other way around, feel free. If I make year 0 to be 5 years ago, then what year is it today? This would be 5. And 20 years from today would be 25. Okay? And then we don't know what the other one's going to be. So what do we know? We know we've got an A value. We're going to need a B value still. Do we have an X and a Y value we could plug into our equation to solve for B? Yeah, so let's go ahead and start up the process that we've been doing. Y equals A times B to the X. And let's fill in some numbers. I know that A is 870. And no b, but that's okay, because I got an x and a y. X is 5, y is 1225. So we need to solve here. Do a little division to start off with. And I'm resisting the urge to put it in my calculator. We'll just leave it as a fraction. Is anybody going with today as year 0? Is anybody trying that? Okay. So if you did, anybody who did that, they would have had a -5 here instead, which means you would have been taking a -5th root. That's totally possible to do, but it feels kind of weird. I don't know. You can take a negative root though. Since we kept it this way without any negatives, we didn't have to deal with that negative root. All right, so I just need to take a 5th root of that fraction. The calculator can do that. Remember, that's under math, but you got to type the root in first. So 5th x radical, and then make sure your fraction is in the parentheses. And I'm going to write down a couple decimal places here, but I'm going to go ahead and store that big long number in my calculator so I can use it and get a more exact answer. It's 1.071. I'll go ahead and stop it there. B is about 1.071. Is that an increase or a decrease? It's an increase. What is the percent we're increasing by? That's about a 7.1% appreciation rate. Math 5. Math 5 is where you get the, and you have to type the number in first. So type the 5 in first, and then math, and go down to the 5th option. So 7.1%. Are we okay going from 1.071 to 7.1%? Recognizing that as an appreciation rate. Great. So now that we have our model, oh, before I forget, let's stow that into B. Stow alpha B. So we can keep the whole long decimal version. We're not introducing too many rounding errors. All right, so what are we going to do next? Well, let's go ahead and write the model down. Running out of space here. So y equals, what did we say it was, 870 times 1.071 to the x. So, great. Well, here's our 2 question marks. So we're trying to figure out the value of the card 20 years from now. So that would be a year 25. Remember, because we started 5 years before today. So 20 years from now would be 25 after we started. So we would just take and type this in and put a 25 in for x. When I do that in my calculator, I'm not going to type in 1.071. I'm going to type in B. 870B to the 25th power. Stow is down near the on button. So 25 years in would be 870, 1.071 to the 25th. Comes out to about $4,815. Not bad. All right, we're trying to figure out where this gets up to $500,000. I feel like that's going to take a long time. If we were to graph this, I would want $500,000 to be up here someplace. which means I probably want my graph to top off a little bit over 500,000. So I'm going to make my graph go up to 700,000. I don't really have any good clues to tell me how far to go out in the X direction. Does anybody want to make a guess? 20 years? 30 years? 40 years. We'll try 40 and see where we get. Okay, so let's go ahead and put it in for Y1. 870. Now, if you stowed that value in for B, then just use B. 870B to the X. And don't forget to graph your horizontal line. And a minute ago, I told you to do the window before you did this. And I just went back on that. Sorry, we'll do the window next. $500,000, right? That's what we're looking for it to be, 500,000. So we need that horizontal line to see where they cross. Let's set our window up. We had our X from 0 to 40. That's a guess. We might have to come back and adjust that. Our Y is going to go 0 to 700,000. And we'll hope we see what we're looking to see. You know, at first it didn't even look like it was drawing, but did you see it kind of creep in over on the side? So we only went out to 40 years, and it is starting to grow, but it's not nearly high enough. So we need to, I think we need to go out further in the X. 120? Okay. So let's make our X go all the way out to 120. So I hope we don't have to wait 120 years, but yep, now I'm seeing it grow. Yeah. Yeah. Well, not when you're starting at only, what, 870, you're not putting any more into it. Like, right, if it was an investment account, you're putting in money every month, that makes, you know, that's a lot different. So second calc intersect to find that intersection point. And again, if you're dealing with exponential functions and you only have 2 functions in there, you can just hit enter 3 times and it'll get it for you. 93-ish years. 93-ish years from today? No. How many years from today? So it would be at year 93, but today is year 5. So how many years from, so that'd be 87, 80, 88, 87, yeah. 88? Yeah, yeah. Well, you guys, advances in modern medicine, you guys will probably still be working on 87 years from now. All right. What questions do you guys have? This next example we're not going to do. Because why? Because it's the same solution. This is the exact same problem. Can you see that this is the exact same problem? Had a y-intercept. It went through this point right here. Right, so my point in putting that on there is you will run across some simpler type problems in your assignment that aren't word problems and look like this. I don't want you to think like, oh, you never taught me how to do that. We did some like that. It's just they're making it a little easier on you. All right, flip over on the back. Talking about half-life. But this is a different half-life than we usually talk about. A lot of half-life problems involve radioactive isotopes. We also talk about half-life a lot in pharmacology, drugs. It's because most drugs will stay in your bloodstream, and they do that kind of the same way that radioactive decay happens. Like, so you'll lose a certain percent of it each day or each hour or however, depending on the drug. And we'll have to come back to Adam's question here in a minute from now about this one too. Does it ever go to 0? Right. But so this happens. So different drugs have different half-lives, and that's good. Like if you have a drug that you want to be in your bloodstream all the time, for example, drugs that reduce your blood pressure, you don't want to take it at like 8 o'clock in the morning and have it like be mostly gone by noon. You want it to like be built up in your bloodstream. So those type of drugs will often have a half-life that's like 3 or 4 days, and you're taking it every day, so that when you take it, it does go up, but it's kind of always kind of staying up at a higher level. But they are going to kind of leave your system by an exponential curve. So this time they're giving us half-life for caffeine, and this is different depending on a lot of different factors, but I think the average is about 5 hours. And we're going to look at a specific example of 1 cup of coffee being about 310 milligrams of caffeine. So we're going to have to start by making a model, and in order to do this, we need an A value and a B value. We're going to end up using this 310 as our A value, but I'm going to set that aside for right now because we don't need that in order to find the B value for a half-life. So I'm going to go ahead and write myself an equation here. Y equals A times B to the X. And I'm going to fill in some values that I don't know. I do not know B, bless you. But I do know the amount of time that it takes for half the stuff to go away. I'm going to use that for X. Then what am I going to use for A and Y? I'll tell you, it is totally arbitrary. Can you put that phone away, please? Thanks. What do you want to use for A? Give me a nice simple number. Just notes right there. Nice easy number. A can't be 0 though. Remember we said A can't be 0. What's the second easiest number? If A is 1, what is Y going to be? What's the definition of a half-life again? It takes 5 hours for what to happen? For half of it to go away. So if we started at 1, then 5 hours later, how much would be left? Half of that. What's half of 1? Half. Now, you could have started at 10 and put a 5 over here. We could have started at 20 and put a 10 over here. It doesn't matter. Doesn't matter. In fact, think this through with me. See if you can do some mental visual math. If this had been a 20 and this had been a 10, I'm going to have to write this down. I can't do what I'm asking you to do. If I had written 10b to the 5th equals, this would be half of it is 5, and I went to solve that equation, what's the first thing I would do? No, what's the first thing I would do to solve this equation? I would divide by 10 on both sides, and I get 5 over 10 equals b to the 5th. And what is 5 over 10? It's a half, right? What if I had chosen to make it 40 and 20? What's the first thing that I would do to solve this equation? I divide by 40 on both sides. I get 20 over 40 equals b to the 5th. And what's it going to be? That's a half, isn't it? So no matter what, we're going to end up with a half over here and a b to the 5th over here. Okay? So it doesn't matter. Choose whatever you want. If it's a half-life problem, choose whatever starting value you want when you go to find b. And just put half of whatever it is over there. If you're smart about it, you'll choose 1 because it's one less step you got to do. I'm not going to divide by 1 on both sides. I'm just going to take a 5th root on both sides. And then I'll use my calculator to get a decimal approximation for that. Then I'll have my B. Comes out to about 0.87. But of course, we're not going to actually use that value in our calculator. We're going to stow the whole long decimal into B, and we'll use the B. Does anybody have any questions about how we found B? Are we good? This question usually comes up, okay? So let me ask the question and maybe you guys can give me the answer. Why didn't I choose to put 310 as my A value when I found B? Because I didn't feel like it. Could I have used 310 as my A value? I could have used 310 as my A value. What would I have had to put over here? If this is 5, then that should be half of 310. What's half of 310? 155. And what would my first step have been? Divide by 310 on both sides. And what's 155 divided by 310? It's a half. So I could have picked anything I wanted for my A value, as long as I'm using half of that value for my Y. Does that make sense? All right, so we got our B value. Now when we go to write our equation or our model, we will use that 310. So we're starting out with 310 milligrams of caffeine in our bloodstream, 0.87 to the X. By the way, the book does this a slightly different way, and you're welcome to do it however you'd like. So the question is, how long does it take until 155 milligrams of caffeine remain in the bloodstream? So what are we going to do here? Are we going to use our math or are we going to use our brains? We could draw a picture. That would be a good start. Or we could use our brains. Let's use our brains. Well, these are all brains things. What's special about 155? It's half of what we're starting with, right? So how long is it going to take us for us to get from 310 to 155? How long is it going to take for us to get from where we started to half of where we started? 5 hours. Why? That's what the half-life is. The half-life is how long it takes for half of it to go away. Right? We started at 310. We're going to end up with 155. I know it's got to be 5 hours. Now, I could actually plug in 155 into my equation and solve it. We could do that if we wanted to. Or we could just say, wait, isn't that the definition of a half-life? Half of it's gone, so it must be 5 hours. All right, now let's do one where we actually do have to do some math. How much caffeine remains after 12 hours? This is 12 hours an X value or a Y value? X. So we'll take our equation and we'll plug 12 in for X. And we'll use our calculators. Did I stow this? I can't remember. Did I stow B? I did. Yes. Cool. So 310 B to the 12th. About 58 milligrams. Milligrams. So a cup of tea, I think a cup of like green tea is around 60 milligrams of caffeine. So 1 cup of coffee, 12 hours later, you've still got the same amount of bloodstream in your system as if you just had a cup of tea. And back to your question from a minute ago, what does this mean about like it never goes to 0, right? Like that cup of coffee that you drank 2 days ago, there is still caffeine floating around in your system from that, right? Yes, yeah, there is. Absolutely. Now that cup of coffee, that first cup of coffee that I had when I was 5 years old, do I still have some molecules of that caffeine floating around in my system? Maybe, probably not. Like out that far, probably not. But there's a lot of molecules. So. I don't think that's true exactly. You can't make new neurons, can you? I don't think you replace brain cells. There's certain types of cells that get replaced. Yeah. We're not going to finish this last one because we're running short on time and we need to do the logistic problem, but let me show you what the equation that I would solve if I were trying to solve this. Hey guys, I don't know what you're doing back there, but make better choices, all right? If I'm talking about 95% of the caffeine being removed from my body, how much is left? 5% would be left over. So let me show you the equation that I would solve to solve this equation. They're saying how long, so I'm solving for x. Here's the equation that I would solve. I would solve 0.05 equals 1 times 0.87 to the x power. And I want to ask you guys the obvious question, which is, why did I not use 310 as my starting value here? Because I don't have to. This problem's about percentages, right? What percentage of the caffeine did I have in my body when I started? 100%, right? And I had 5% left at the end. So as long as you're being consistent, you don't have to use milligrams, you could use percentages. I could have gone 100 here. If I'd gone 100 here, what would I have put over here? 5. Question?
Did you say that the left side has to be half of like the first, like where the 1 is?
The left side has to be half of this when we are talking about the half-life. Okay, so if this was a 5, right, because 5 is the half-life, then you're right. Those two things would have to be half of each other. That's a great question. Thank you. Any other questions before we move on to logistic? All right. I want you guys to work on memorizing this form of the logistic function, the one that has the A's, B's, and C's in it. Y equals C over 1 plus A times B to the x power. I want you to work on memorizing that one. All right, so here's the situation. We've got a high alpine lake. Something happened. All the trout got killed off, so somebody decided to go stock it with 200 trout, bring them back, and they're interested in letting people fish, but they want to make sure it gets up to a nice, healthy population. So they come back after a couple of years and do a survey, and they estimate there's now 315 trout in the lake. Is that good? That's very good. That means they're reproducing, right? Now, the ecologist says they think they could probably sustain 850 trout in a lake. There's a certain amount of space and a certain amount of food in that lake. You can't have 1 million trout in the thing. And they want to make sure that the population gets up to around 700 before they let people fish off of it. So let's make a logistic model that's going to model how many fish are in the lake. Okay, so what do we know? A, B, or C? We have one of those numbers. We have A. Is A the initial value or the y-intercept for a logistic function, though? Is A the y-intercept or the initial value for a logistic function, though? No, that's why I put all these stars and all these underlines around this little note. Did you guys put this in your note at the beginning? Yeah. It is so easy to make this mistake. I have made it like at least a dozen times. A is not the starting value. It's not the y-intercept. So we don't actually know A for this yet. We don't know A for this yet. We do know one of those things, A, B, or C. It doesn't really have we know C. C is the carrying capacity or the kind of the theoretical maximum, which is 850. So we know C. We know C is 850. In fact, I'm going to write that here. C is 850. And we've got some data points, so let's maybe make a table. If we're assuming the initial population had an x value of 0, let's go ahead and make that assumption. So that'd be 0, 200, and then after 2 years, we're at 315. So we got C, we're missing A and B. So how are we going to find out? We're going to plug some points in. And we're going to probably end up plugging both of those points in. Well, not probably, definitely ending plugging up both of them in. So I'm going to go ahead and write my function. What do I know so far? I don't know A or B. I'm leaving out my X and Y. What I do know is that C is 850. And let's pick one of those 2 points to plug in first. And my advice to you is go with the simplest one, 0 and 200. And when you write it and you start simplifying it, you're going to see why. What's that 0 going to do to the B? Turn it into a 1. So that's going to go away, leaving you with an equation that only has an A in it. Oh, we can solve that. That's good. So we're going to solve this for A. Once we know what A is, we'll come back and plug it in and solve for B using the other point. We're going to resist the urge to put things into our calculator. Let's see, I'm going to probably multiply by 1 plus A on both sides. Guys, don't just copy off the screen. You can do this math. You've done this math. Stick around after if you're dying to see your test. I'm hoping to. My priority is make sure we're still moving ahead. I'll do my best. We can simplify that. I'm going to let my calculator do the... It's not that that's terribly heavy lifting, but 65 over 2. And I'm leaving that as a fraction for a very specific reason. I'll tell you why in just a moment. That's not right. I didn't type that in right. There, 13 over 4 sound better? (13 over 4). They're both divisible by 50. 13 over 4. $650 came from doing minus 200 on both sides. Now that is 12.25. We could put that in as 12.25 and we're not losing any information, but I'm not going to do that and I'll show you why in a second. What's your question? Why are we what? Anything to the 0 power is equal to 1. Yep. Except for 0. B is not going to be 0. All right, so we're going to go back and do the same thing we just did with the other point, but now we've got a value for A that can go in here, and we'll be able to solve for B. So I'm going to go right next to this, and I'm going to rewrite this equation. I'm not using the 200 this time, though. I'm going to use the 315. Now this is going to get messy, but this is like Algebra 2 level work here. You can do it. Start by multiplying to clear your fractions. So that cancels and clears. Yikes. 13 over 4 times 315 as a fraction, please. Guys, all right? I know we're not fans of the huge fractions, but that's all right. Sometimes things get messy and we just got to deal with it. Minus 315 on both sides. Do y'all remember how to remove a fraction that's multiplying? How do I make this go away or turn into a 1? Multiply by, here, someone whispering it. Starts with an R. Must multiply by the reciprocal. Oh, don't worry, you got a calculator that'll do it for you. It's not that bad a deal. Come on. We're strong. We can handle this. 535 times 4 over 40, 95, and also please turn it into a fraction for me. All right. 428 over 819. That's just b squared now. Oh, we're so close. So b is the square root of 428 over 819. Boom! And we're just going to leave it like that. I'm not even going to bother turning that into a decimal. Actually, just so I don't have to keep typing that in over and over again, I might go ahead and turn it into a decimal and then stow it as b, so I don't, just out of laziness. So we're going to wrap this up now. My final function is y equals 850 over 1 plus 13 over 4 times square root. And I do have some good news for you guys here. You guys are going to be so grateful for this. Maybe, maybe not. Sorry, you can't see that. That's my final answer there. Almost any other time this year, if I saw a fraction inside of a radical, I would say you need to split that up and rationalize that. We can't have radicals in the bottom of a fraction. This will be one of the few exceptions. We're not going to rationalize this. It's messy enough as it is. So you may leave inside of logistic functions when you find that b value, if you have a radical, and you often will. A lot of times it's going to be a cube root or a fifth root or a 10th root or something else like that. You can leave it as it. However, I do not want decimals inside of the radical. I want reduced fractions. Your calculator will do it for you. So this got messy, but not terrible. Now, we didn't answer the question. How would we answer the question? Well, I'd graph this. And I'd graph that line y equals 700, and I'd see where they intersect. Okay, so we know how to do that. We've done that 3 times today. Question? 13 over 4 times 315? Does yours look like this? Line looks just like that? Bring me your calculator. Let me see that. That's interesting. All right, folks.